Hello and welcome to another one of D's ADD videos. Today we're going to be discussing the concept of magnetic force. What is magnetic force? Well, anytime you've got a charged particle or a current, which is a bunch of charged particles, we're going to create a magnetic field. And then this magnetic field is going to have a magnetic force that it exerts on other charges adjacent to that original moving charge or charges. All right? So we've got something moving. It's creating the B field. The B field is going to be then creating a force on anything around it. So magnetic force depends on a few things. It's going to depend on your charge, the magnitude of the charge. It's dependent on the magnitude of the magnetic field and the velocity. Those are what dictate the magnetic force. This is the formula. The formula is going to be the absolute value of the charge times the velocity, okay, scalar times a vector, and then cross product the magnetic field. So the alternative definition for cross product is the product times the sine of the angle, and you do the magnitudes of the charge, the velocity, and the magnetic field times the angle, and the angle is the angle between the velocity and the magnetic field. The SI unit for force is newtons. You should remember that from mechanics and heat class, physics 1, and all the other force problems we've done in physics 2 as well. And you can remember that the magnetic field is a Tesla. All right, so we know the SI unit for force is newtons, and we know charge has a SI unit of coulombs, velocity is meters per second. So we can get the equivalent of what a Tesla is by dividing both sides by the QV, provided the angle is 90 degrees. We can say that it'll just be QVB. And then we can look at the units, and a Tesla will be a Newton times a, whenever the meters per second is on bottom, if the seconds flips up on top, and you're going to get, and then you're going to get 1 Tesla equals this. If you remember, an amp is a coulomb per second, so since the coulomb is on bottom and seconds is on top, the amps would have to be on bottom. So these are just what 1 Tesla would equal. All right? So basically, that's it. If you want the direction of the magnetic field, you're going to have to use the right-hand rule. You start out by putting the vectors of velocity and magnetic field tail to tail. Then you put your fingers into the arrowhead of the magnetic field. Then the fingers go down the velocity vector, and then they curl towards the B field. All right, so put velocity and B vectors tail to tail, fingers in the arrowhead of the B field, down the velocity vector, curl towards the B field. And then where your thumb points, that's the direction of the force. All right? So I hope I've clarified magnetic force enough for you to try some problems. The next topic will be magnetic fields and magnetic flux, and then we will discuss the effect of magnetic fields on groups of charges. All right? So practice, practice, practice. Check out the example videos, and as always, have a nice day.